Okay, have a good day, students. Today in this lecture, we are going to see about the photovoltaic effect in semiconducting materials, the semiconductors, and some other thing like exciton. While the light photon is incident on a semiconductor material, it will generate the exciton and the types of exciton. So these are the things we are going to see in this lecture. So photovoltaic effects. From the name itself, you can say that when the light photons are interacted with the semiconducting material, it will generate voltage because of the potential difference generated there. Okay, so this photovoltaic effect is used in the photovoltaic cells, which is nothing but the cells that is used in the solar panel, and they are otherwise the solar cells are called as photovoltaic cells. So photovoltaic cells which use the principle of photovoltaic effect. So it's a process of generating voltage, as I said, and when you have the voltage, and we can use it for domestic purpose to generate electric energy. So this is used in the solar panels. You know the solar panels, what we are seeing for the domestic purpose. In our college itself, above our department, we have some solar panels are there. In a lot of buildings, we have these solar panels. So these panels consist of small segments. They are called as cells. So each one is a cell. 1, 2, 3, 4. Likewise, these are cells, and they are together. It is called as panels, solar panels. So these panels, solar panels, are useful to convert solar energy into electrical energy. So using this principle, the conversion is taking place. Okay, a few more explanation is here. So the photovoltaic effect occurs in the solar cell. Here, the solar cells are normally made up of silica based solar cells are there. Then cadmium, indium, gallium, sulfide, CaGS based solar cells are there. Then inorganic solar cells, organic solar cells. Then recently there is DSSC, dye sensitized solar cells. So different types of solar cells are there. They are made up of different materials. So plenty of research are still going on to improve the efficiency of the solar cell. So the conversion efficiency, okay, the conversion efficiency of the light into electrical energy is very low. Anyway, we can use it for certain extent. Nowadays, the efficiency is much improved than the first invented solar cell. So still researches are going on. Okay, so the solar cell composed of two different types of semiconductors, as we have studied. There is a p-type semiconductor and n-type semiconductor, and they are joined together to create a p-n junction, like this diode p-n junction, p and n. So while the light photon incident on that, it will create holes and electron. Okay, so the holes will move towards the positive side, and the electrons will move towards the negative side. And due to this, potential difference occur, and they can be stored in the grid. Okay, so plenty of cells are there, so we can store it in the grid and use it for the further purposes. So here you can see the diagrammatic representation. Photons are incident on it. So the electrons receive the energy and it will get emitted. So it is normally mentioned in the case of metal. So it will just trigger the electron to move on. Okay. So, but we are discussing with the help of this semiconductor, since it is the interaction with the semiconductor. Okay. Further, let's go on with these explanations. So, as you know, light is consists of the photons. So they are simple bundles of packet of energy. So when the light of certain wavelength, so when they incident on the panels, solar panels, which consist of the cells, so that energy can be absorbed by the semiconducting material, and the energy is transferred to the electron in the material, and which in turn leaves a hole. So there is a electron hole pair formed. I said. So whatever I have said, that is explained descriptively here. So here the excitation takes place, the electron excitation takes place. In some cases there will be no excitation. So when unexcited, the electrons hold the semiconductor material, and it will form the bond with the surrounding atoms. So as we have discussed, the silica and germanium in the semiconductor. Normally silica is used in the solar cell. So you know that it forms covalent bond with the neighboring silica atoms. Okay, here it will form. So 4 electrons are there. So here, wait. Yes. So here too it forms the covalent bond. When the photon incident, it will get breakdown because of this energy, and it will remain free, and it create a hole here. So that is the actual thing happening. Now electron and the holes move in the opposite direction. Electron and hole move in the opposite direction. Here the freed electrons move towards the inside, and this motion of electron creates the electric current in the cell. So henceforth it is used to store the electrical energy. So that is the use of this photovoltaic cell. So we have discussed about the photovoltaic effect and the photovoltaic cell, solar panel, and what is going on while the photons incident on it. That is the sunlight uh, incident on a semiconducting material. Now the excitons. Let us see the excitons. What is that exciton? So you know that a semiconducting material, it has a valence band and a conduction band, and when a photon of energy is less than the energy gap, so this is the energy gap, it has certain value, e.g. okay, normally for semiconducting material it is from 1 to 2 electron volt. Somehow it is, sometimes it is about 2.5 also. Above that, above 3, it will called as insulators. Okay, so here For example, you just think this is 1.5 electron volt. So in some cases, if this photon energy doesn't meet this energy level, then there will be no movement of electron from the lower level to the higher band. Okay, so hence we need more energy to move the electron from the lower level to higher energy level. When it is less than this energy gap, here what happen means they won't go to the conduction band exactly. It won't reach the conduction band exactly. So instead of that, just below that conduction band level, and they are called as exciton bands. Exciton bands. Okay, so this is what mentioned here. Okay, discuss further. Look at this. So here, this is a bounded form of electron and hole. In this case, here you can see the free electron is still bound to the hole in the valence band because of the Coulomb force of attraction, and this electron hole pair is called as exciton. So hope you understood what is the exciton. That is the electron hole pair, and which is nothing but the bounded electron hole pair. This is happened because of the combination of electron in the exciton energy level and the hole in the valence band. This is called as exciton. There are two different types of excitons are there. One is weakly bound exciton and another one is tightly bound exciton. Here, the weakly bound excitons, this electron and hole interparticles distance is large compared to the lattice constant. Okay, so the electron and hole interparticle distance is large. They are weakly bound. So, for example, a positive hole and electron. This distance is large when compared to the lattice constant. So, we have seen this lattice constant in the crystal physics. In crystal, in cubic crystal, it is called as A. The distance between the atoms. Okay, so that is small when compared to this distance. This is large. Okay, since it is large, there will be no chance of attraction here. So the cuprous oxide has weakly bound exciton. So this is the example for weakly bound exciton. And then the tightly bound exciton. Here you can see that the tightly bound exciton, here the distance is very small. The electron hole interparticles distance is lesser than the atomic radius. Even the it is very smaller than the atomic radius itself. So it is very nearer, uh, and so the force is also more. That's why it is called as tightly bound excitons. Okay, so this is happen in the alkali halide crystals such as sodium chloride and potassium bromide, etc. So they have the tightly bound excitons. Okay, so hope you have understood the today's lecture. So we have discussed about the photovoltaic effect and also the excitons and the different types of excitons. That is weakly bound exciton and the tightly bound exciton. Okay, see you in another one lecture. Until then, bye from now. Thank you.